Hello guys, in this video we are going to discuss the solution of the problem index of an extra element. So let us look at the problem statement. The problem statement says that you have given two sorted arrays AR1 and AR2 of distinct elements. The first array has one element extra added in between. Return the index of the extra element. So for instance, the length of the array which is given to us is 7, and the two arrays which are given to us are these two arrays. Out of this, if you see in the first array, the element 9 is extra and the element 9 occurs at index 4, and that is why we are returning 4 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of the problem, let us take the array which we have. So as mentioned in the question, the length of the array is 7 and the first array is this and the second array is this. And as mentioned in the question, these two arrays are sorted. Now since these two arrays are sorted and we need to find a missing element or an extra element, what we can do is we can apply binary search here. Now let us see using binary search how we will be able to find out the extra element. So for binary search, as we know, there will be a start pointer and initially the value of a start will be 0 and then there will be an end pointer and the initial value of end will be n minus 1 which is equals to 6. Then we are going to compute a mid pointer and mid in this particular case will be 3. So the third element, if you see, this is the third element. Now once we reach to a mid position, what we are going to check is we are going to check if ARR1 of mid equals to ARR2 of mid. If these two elements are equal, then that simply means that array start to mid are same. The array ARR1 and the array ARR2 from start till mid position, they are both same. Since array 1 and array 2 are equal till mid position, thereby the searching of the extra element should happen between mid plus 1 to end element. And that is why in this case, what we are going to do is we are going to update our start pointer to mid plus 1. So the start pointer will be updated to mid plus 1, which is equals to 4. Now, like in binary search, we will again find out the mid position. So the mid position for 4 and 6 will be 5. And the fifth element, if you see, is 10. So this is my fifth element. And the fifth element in ARR2, if you see, this is 12. So as soon as we realize that the elements are not same, so this condition does not hold. As soon as we realize that the condition does not hold, so that simply means that the extra element is now somewhere between start to mid minus 1. And since the mid position element is not equal, so what we are going to say is the extra element is ARR1 of mid for now. It might be possible that this element is there in ARR2 also. So that is why we have to search between these two indexes also in order to be sure that we return the extra element rather than the element which are present in both the arrays. So let us proceed forward. So as discussed, the end position, so in this particular case the end position will be shifted to mid minus 1, so end becomes equals to 4. And remember, start is 4 here. So again, just like in binary search, we will again go ahead and compute the mid position, and the mid position this time will be equals to 4. So now we are going to compare the fourth element. So the fourth element is this element, which is 9 in first array, and the fourth element of ARR2 is 10. So again, the fourth position of array 1 and array 2 differs, because of which we are going to update our answer. So now the answer will become equals to 9, which is equals to ARR1 of mid, and our end position will be updated. So now let us update our end position. So the end position will be updated by mid minus 1, so end becomes equals to 3. Now since start is not less than or equals to end, because of which we'll break our loop, we are going to return the mid position, and that will be our answer. So that's the discussion, folks. Now let us see the pseudocode for this problem. So let us say we want to find the missing element, and two arrays are given to us, A and B, and the length of the bigger array is given to us, and let us say that length is n. we are going to set a start pointer which is initially equals to 0 and an end position which is initially equals to n minus 1. Then we will have our answer, and the value of answer initially, let us say we are setting it to 0. Now we will iterate on the array till start is less than or equals to end. Now as in binary search, we are first going to compute our mid position. So mid is equals to start plus end minus start divided by 2. Once we have our mid position figured, what we are going to do is we are going to compare whether the mid position of Ath array equals to the mid position of Bth array. If these two elements are equal, then that simply means that the array from start to mid is sorted in the sense they are equal, because of which we have to search our missing element or the extra element in the range of mid plus 1 to end. That is why we are updating our start pointer here. Otherwise, if let us say they are not equal, then in such case our answer will be equals to mid. So this is my potential answer for now. And then we are going to search for the missing element in the range of start to mid minus 1, because of which we are updating our end pointer to mid minus 1. And once this loops end, towards the end, what we are going to do is we are going to return answer. So that's the code, folks. Now let us see how we have implemented this in C++ and Python. So first let us look at C++ implementation. So we have a start pointer, and then we have an end pointer, and then the answer. And just like in binary search, we will iterate on the array till start is less than or equals to end. Then I'm computing my mid position. Then I'm checking whether my first array mid is equals to the second array mid. And this is an extra condition which we have added, where mid is less than or equals to n minus 2. The reason why we are doing this is because the second array is one length shorter than the first array, because of which we have to ensure that we don't exceed the boundary of the second array, and this condition ensures that we don't exceed the boundary of the second array. Now if this condition holds, then start is equals to mid plus 1. Otherwise, answer is equals to mid and end is equals to mid minus 1. And once this loops end, we are going to return an answer. So that's the code, folks. Now let us submit our solution. So the C++ solution got accepted. Now let us look at our Python implementation for this. So it is pretty much the same. We have our start pointer which is equals to 0, end pointer which is equals to n minus 1, and then we are iterating on the array while start is less than or equals to end. Then we found our mid position. Once we have our mid position, we are checking whether the Ath array mid position is equals to Bth array mid position. If they are equals, that simply means that array from start to mid is sorted, because of which we have to find the missing element in the array mid plus 1 to end, because of which I have updated my start to mid plus 1. Otherwise, answer equals to mid and in end is equals to mid minus 1, and towards the end I have returned answer. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.